All right. So again, if you're just coming in, here is the Google Doc to our landing page for today with all the resources. And this is using movement to drive three-dimensional learning instruction. So if I was presenting this in the wild, I would be having all of you get up and move to a corner. So in the chat, if you just want to tell me, how often do you get your students moving in your classroom? Try not to think about the first day of school. I know that's like herding cats to a bathtub, but think about like maybe after 3 or 4 weeks of being in the routines that you are setting up, how often are your students moving? Rarely, sometimes, often, or constantly? 3 to 4 times, often. Often. Okay, I love this. So yeah, we want to get our kids up and moving. Definitely. I can't even sit for that long. Oh, I love this. Try to do it every 17 minutes. That's fantastic. That's a goal. Like even at an upper grade level, that should be a goal because even as adults, we need to be up away from our desks at least once an hour because my watch reminds me of that. All right. So thinking about the impact that has on your classroom for a teacher, we may have some brand new teachers in here. So if you do a lot of movement in your classroom, what impact does that create in that learning space? Is it worthwhile to even focus on that? Um, I mean, I've got people purposely dedicating time that y'all are saying in the chat. So we're seeing that it's powerful just in that aspect, but just being able to share a reason why to another teacher might also be helpful. So feel free to drop some thoughts in the chat, and then I'm going to keep moving through the presentation. We've got, I feel they pay better attention if they know it won't be too long. Definitely. What grade do you teach? You might have told me up ahead. First grade. Oh, definitely first grade. Absolutely. All right. So, one of the first things I do at the beginning of the year is set some norms with my students. So they know that think time is protected. And y'all, I have a son in pre-K, 4 years old. He'll be moving into kindergarten this year. Think time being protected was a battle for him because he thinks really quickly. So that was hard. And he hated that norm that I would set for students. That's not a fun one for him. He doesn't want to do that one. That's a huge life skill that he had to learn this year. But think time is protected for everybody. We need to be okay with disagreeing with evidence, especially in science, because we're still working our way through the phenomena that we are experiencing and processing what is happening, right? We want to build on each other's ideas, and everybody should get a turn to talk, okay? So our objectives today, we're going to experience movement as a learning tool. We're going to connect it to our three-dimensional science standards and then look at some strategies that you can bring into your own classrooms. So we know that talk, oh, Brandy, I was taught our brains need a break every 20 minutes, and that switch helps us avoid mental breakdowns. So going back to my mental health stretch, absolutely, kids need those breaks. I love that. All right, so we know that talk matters in science. We have to talk out the phenomenon that we are experiencing, trying to figure out what the science is that's actually happening, understanding the world around us. We know that part. And we're going to add on by also discussing that other layer of movement. If students are physically engaged, it's going to cause their thinking to deepen, especially if they can be part of the simulation or the model that they are trying to create. So when students move, we are not pausing learning at all. We're literally increasing their brain's ability to process information. And this is critical for that three-dimensional learning. Students have to process, not just receive information. So in science class, it can't be a sit and get lesson every day, all day long. That's not how our science standards are written. Our science standards are very active. So I'll break those down a little bit more in a second. But movement is going to build our memory. So BDNF is a protein that supports the survival, growth, communication of those neurons that we have, playing that key role in learning, in memory, and overall brain health. And if we want students to remember science concepts, movement is not optional. It supports how memory forms. And so we're able to link our disciplinary core ideas, and that is going to help retain that content knowledge. So when students stop paying attention, it's not always behavior. Teachers might think, oh, well, they're just, acting out. Um, it's biology in most cases. So students get fatigued. Their brain, they're just done. They need a moment to process. They're overwhelmed, and so that could be them not wanting to act out and be bad in the eyes of the teacher, but their body needs to move. So movement is not just an engagement piece, it's a pathway to scientific thinking. The student becomes a very active participant. They're able to have discourse. In a lot of these activities, there's that argumentation happening, reasoning, and this is also bridging our science and engineering practices. So what is movement? Well, movement is anything that engages the body, okay? So my question to you, if I were to ask you, what does it mean to think like a scientist? Or, what is a scientist? What comes to mind for you? Maybe or an engineer? What kind of definition would you give? And if I were to ask you to draw a picture of a scientist, questioning, experimenting, look at things and how they work, exploring, observing, trying a theory. Yeah, so lots of movement, investigating, explosive tests. Oh, all the fun ones, right? Messy recipes, uh, looking at everything with a questioning, wondering eye, someone who likes to question. Yeah. And who is the best scientist? Who makes the best scientist? In my eyes, a 4-year-old. They are the best scientists that we have out in the world today because they ask questions about everything. And it gets exhausting when I go grocery shopping, but he is building that oral language that is so important for his development in reading that comes later. So, as exhausting as those conversations are, that language development is super, super important. So, the littlest ones are really great scientists. So three-dimensional learning, you've heard me say that a couple of times now. Our standards, when you first look at science, can seem overwhelming, but they're broken into three pieces. That's where that three dimensions comes from. Science and engineering practices, that's what the student is doing. Students are always doing something with the standard. Disciplinary core ideas are just what's the science, right? What are the facts? So physical science, life science, those kinds of things. And then cross-cutting concepts are how ideas connect across science. So I'm going to break this down even more. So our science and engineering practices, remember, this is what students are doing. Asking questions, defining problems, developing models, using models, planning investigations, doing investigations, looking at data, interpreting data, collecting data, using math, computational thinking, constructing explanations, designing solutions, scientific arguments, using evidence that they've gathered, communicating information, right? So to the group that was here when we first got started, I had said, I can teach science all day long and hit every subject area. And Brenda probably agree. She feels the same with social studies. So those are your two content areas where you get that background knowledge to bring into a literacy classroom, right? Because kids have to know something to do something with it, right? So my science and engineering practices, this is what kids are doing. And in our standard, this is where they would fall. So we have it broken into those three pieces. So this is a third grade standard. The performance expectation is in that tan color. Make a claim about the merit of a design solution that reduces the impact of a weather-related hazard. And so there's an asterisk next to this one because it emphasizes engineering. That's all that means. And at the bottom, you'll notice there's a connection to scientific literacy, and there's four components to that. This is not a testable part of our standard, but we just like to call it out where we can. So science here is a human endeavor and it affects our everyday lives. Okay. So this is an image of one of our new standards for this year. All right, then we have in the middle in that reddish orange color, disciplinary core ideas. There's four of them. It's either going to be about physical science, life science, earth and space science, or engineering, technology, and applications of science. And so here with this standard, these are just the facts that we want students to get to, right? And use to work through some of their ideas. And then we have our cross-cutting concepts. So here students are looking at patterns, they're looking at cause and effect, scale, proportion. I like to think of that when I'm teaching like water cycle, because a lot of our kids in Oklahoma have never been to an ocean. They don't understand how vast that can look and how the water cycle actually works. It's not actually a circle. System and system models, energy and matter, that's in fifth grade, we're talking about dead stuff, all the fun things. Structure and function, why things are designed the way they are, stability and change, which we're going to see stability and change today in our activity. And so again, those fall in that far right section of the standard, and you'll see them coded in green. Okay, so real quick practice, if the science standards are new to you, I'm going to just say something, and you're going to tell me if it is SEP, Science and Engineering Practice, and if it is, you're going to touch your brain. Remember, that is what a student is doing. And then we have our disciplinary core ideas. So if I'm talking about like a science concept, like energy transfer, or decomposition, then you're just going to put both hands up in the air to practice. And then cross-cutting concepts, you can just make a circle over your head with your arms, or you could do that to show cross-cutting concepts. Okay, so asking questions, where would that fall? So that's going to be our students doing, right? We want our students asking questions. Cause and effects, making cross-cutting. So that's going to be connecting. Energy transfer. That one's going to be both hands up like a roller coaster. And then if I ask my students to model something, that would be science and engineering practice, touch your brain. Okay. Those are hard and it takes time. It's all good. It all meshes together. All right, so we are going to look at what this looks like as students, and I'm going to kind of walk you through some of the standards that we're going to hit on. I'm also tying this to physical education. So we're going to look at standard 1, where students are describing healthy ways to express, what they need. But we're going to do this in the relationship of us being deer. Okay. So what do deer need? And then standard 4, they're going to be communicating. So having some discussion about what happened during the simulation, and also non-verbally communicating what they need as they play the role of the deer. Now in science, this game can be played all the way down to little ones, but I picked 3 standards where this really fits in nicely. So 5th grade, using models to explain or predict factors that upset the stability of local ecosystems. 7th grade, you're looking at interactions among organisms across multiple ecosystems, and then in high school biology, using mathematical representations as evidence to support biodiversity, like the factors of biodiversity and populations. Okay, so before I even get started with my students, I want them, my kids just know every day for the first 2 weeks of school before we even get started with learning science. We do a lot of practice each day with what do you see, what do you think, what do you wonder? And I'll just put up a random picture. It could be of anything. The first one I like to always start with is Nemo's Garden. It's an underwater gardening place where they're doing lots of experiments, but just to see a picture of this bubble underwater and it looks like there's plants inside the kid, like it causes kids to start asking questions. So they have to tell me, what do you notice? What are you seeing? What do you think is happening? And what questions do you have? And so I have them talk to each other. It reduces the fear of actually putting it to paper. When in older grades, fifth grade, I don't have that issue as much, but they like to turn and talk to kind of get a feel for what they actually want to put on paper. With my students, I'll have them put them on Post-it notes sometimes, and we'll kind of organize what the class has come up with, especially when we're actually getting into a science concept. So for the activity today, this would create a driving question board where my kids are putting their noticings, their wonderings, what do they think is going on? They're starting to make a web. It looks like a serial killer like investigation thing across the board. It's massive, but they're trying to piece together what is actually happening. And that's the goal. And so I always have talk moves to encourage that conversation. So this is the chart that I kind of create. I print it at 80% and give it to my students in younger grades. But by third grade, my kids just know, like, draw this in your science notebook. And so they just draw the 3 columns. They put see, think, wonder, and then they put their ideas. So we just get in the habit of doing this. So again, I spend the first 2 weeks of school. It takes 10 minutes. It'd be a great brain break to just put up a funny picture, have them practice. What do you see? What do you think? What do you wonder? And then kind of going through what they're looking at. So let's try it. All right. So in the chat, you can drop what do you see in this picture? What do you think is happening in this picture? And what questions do you have? Feel free to share any of those. Where's mom? Yeah, that looks like a little deer. That's a little one. So where is mom? I noticed that this it looks like a baby is walking through water. So I can talk about the habitat. Um, the deer kind of looks like it's looking at something, so I'm curious like what it's watching. All right, so we've got some more dropping in. I see a deer. I think it's getting a drink. Wonder if it's lost. Wondering, see a wandering baby. I think mama might be close by. Maybe mom is giving a lesson on independent. Yeah, see a fawn standing in a stream. I think he's getting a drink of water. I wonder where mom. Yeah, we're all definitely teachers. Where's the adults? A teacher walking, or sorry, a deer walking down a creek at night. Someone is following with a flashlight, maybe. Yeah, because like it kind of looks dark for the rest of it. Maybe light is coming in. Are there more deer in the area? Maybe looking for mom. I wonder what happened. Yeah. So, okay, sorry, Rory, this is probably traumatizing for you to see a deer. She she hit a deer, what, last year? Anyways.
The deer hit us, let's be
Oh
clear.
yeah, sorry. It ran into them. Sorry. The deer was at fault. Okay. All right. So again, getting my kids to have these conversations. All right. I don't like deer for the same reason. Y'all, all right. I'm from Charleston, South Carolina, and the school that I worked at, I had to drive along this marshy road. So it was water on both sides. And so when I got to that section, because I taught on an island, I never worried about deer because it's water on both sides, right? Well, one day a deer comes right out of the marsh, like right across my car. So I learned really quick. They just come out of the sky apparently. Anyways, all right. So I always have norms for my students. So, or we're going to stay safe today when we do this activity. I let my kids, because we play this outside. And if you play this with adults, it's a lot of fun too. So feel free to steal this for your next party get together. I did this with teachers the other day, and there was like a day porter kind of cleaning up around us, and he wanted to join in. So it's a lot of fun. But stay safe, move safely. When you come into contact with another person, do it gently. Let's not tackle or put hands on each other to where someone's going to get hurt. Commit to the role. So if I tell you you're a deer, you need to be a deer for that moment, and unless your role changes during the game. And then you also need to be ready to reflect. Okay, so this is the conversation that I'm always having with my kiddos before we play the activity. And learning is going to feel chaotic at times, but it's important. All right, so oh dear. So my students are either, to start us out, a deer or a resource. Okay, and I count off how many I want of each depending on my group size. Now, if you are a PE teacher and you want to do this with a whole group, like at my school, there'd be 60 kids in PE. This would be a really fun game to play with 60 kids at a time. Because then we can add in some other components to this. So I've got my deer on one side. You can give them little color coded wrists. I mean, you can label them like they can hold cards. You're going to see that in a video. You could give them a little wristband to wear or a flag to hold, whatever. I just tell my kids, I try to make this as uncomplicated as possible. You're a deer, you could walk around like this if you wanted to. Okay. Um, and then my resources are either going to be food, water, or shelter. So for food, I might have them touch their stomach if they want to be food. If they want to be water, they can hold a glass like this to show they're going to drink water. If they're shelter, maybe a little thing above their head to show a house. Okay, so food, mine are touching their stomach, water, or shelter. Now, deer need to make a choice and they can't decide amongst themselves. It's just one deer deciding what they want in that moment. I want a glass of water. Okay. So everybody, I like to have them pretty far apart. You could do opposite sides of a gym or down the hallway from each other if you want to play this in the hallway. It's probably not a great game to play in the classroom, but if the weather's nice, get outside and go play. So they turn away from each other. They're lined up. You'll see this in the video in just a second. And the deer have to decide which resource they are looking for, and the resources have to decide what resource they want to be. Can all the deer want to look for water? Absolutely. Could all the resources want to be shelter? Absolutely. And if there's no match, the deer die. So now we have all the deer gone and we've got a ton of resources, and that could happen, right? So what happens is that you want to match up a deer, what they're looking for, with the need that the resource that they need. Okay. Once there's a match made, you can't share resources, like it's one to one. And so once a deer has found its resources allow them to reproduce. So now we have two deer. So now you've got two deer that have been added back to the deer population. Okay, if a resource does not get picked, it stays a resource. If a deer does not find a resource, then it dies. And so it becomes a resource. Okay. Now, you can make this game even more fun because once they've played this a few rounds and you're keeping, like I keep a tally mark of how many deer, how many resources, and then we just play round by round. And I call it year by year. So we can see the population change year by year, and we'll play it for a couple of times. And then we have hunting season, or we have cars, a highway's been built. And so some of my students are now pulled to be, we'll decide, are we going to have wolves enter our population? Are we going to have, cars enter the population habitat? We'll make a decision. And then we play again. So a deer can get caught by a wolf and get eaten, and then it becomes a wolf. So now it's now no longer a resource or a deer. We're adding to that change and stability. Okay. So it gets really fun really fast. And the kids start to see okay, the deer population decreases now that the wolves are here, but the wolves can only grow so much before there's not enough food for them to have either. So there, that stability and change is inevitable. It's going to happen, but things will all, like they find ways to stabilize. And so getting kids to see that in this game is a lot of fun. All right, so I'm going to switch screens to show you how this game, and it may not have volume, so just bear with me on that. I just wanted to share the actual video with you. So let me show this. Okay.
This part of the classroom, you guys are all habitat. And I want you to think which type of habitat you want to be. Shelter, food, or water. And on this side of our playing area, we have 6 deer. Okay? Would you 6 deer turn around and face the other way? Okay, deer, decide what you want to eat this year, what you need to survive. Pick one. Habitat, pick what you are this year. Hold it by your stomach. Okay, so we have, let me see it. We have, okay, don't change. Decide what you're going to be. What are you going to be? You can't be a deer yet. Show me. Food, shelter, food, shelter. Oh, look at this. Okay, 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 okay. So I think we're ready. 1, 2, 3.
Oh dear!
Now, we have 6 deer that need habitat. Deer, you walk across and tag one that is matched to what you need. Go ahead, walk.
Yeah, I have my kids
And
on.
bring them back.
They do a good job with it.
And what do you think about the population this year? It was 6. What is the population now? How many deer do we have? Did all the deer survive? Yes, we have 12 deer. It was a good year for deer. Habitat? Oh, not so good. Okay, so we've had 2 years. Let's continue. All right, so year 3 was really good. How many deer do we have in year 3?
Year 3, we had 22 deer.
22 deer, except for one poor little deer right here that was looking for food. What happened? Deer, what happened?
I died.
You died. You didn't get any food. So now you're going to decompose and you're going to turn into habitat. So get over there. All right, now I got a question. We have 3 habitat left and 22 deer. What do you think is going to happen to the deer population this year?
Go up.
It's going down. Deer, turn around. Pick what you need, and habitat, decide what you want to be. Ready? Somebody's looking. Don't let them look. 1, 2, 3.
Oh dear.
Oh dear. Here we go. Only. All right. The rest of you died. The rest of you over here.
I died.
The rest of you.
All right, let me hold on. I gotta minimize this real quick. Okay. So let me share back to the presentation. All right, as I'm moving back to our PowerPoint, what were your thoughts on that? Could you use this with your students? Are you thinking of some ideas to change this up? I would love to know all the things. Feel free to drop that in the chat. And I'm glad you could actually hear it. 3rd graders would have loved it. Video, yeah. So there are people that have turned this into an actual simulation. You could have kids make this into a video game, like through Scratch or anything like that. My robotics kids, I've had them play a similar game with their robots. You could get really creative with this. Okay, I'm gonna share this link to my one pager again, just in case somebody came in after they saw this. Okay, might change a tad. Oh yeah, 1st grade would look a little different, definitely. But have fun with it. Don't be afraid to try. It may be a flop the first time, but it could be a game that you start to bring in as like a group play activity for, just whenever y'all want to get outside and have a break for a moment. Okay, so thank you for sharing some of those thoughts with me. Now, why does notice and wonder work? Well, it's a really great way to introduce a phenomenon or a concept that we want to get kids talking about. It's a great way to have our kids practicing those observation skills, and it really builds on their conversation developments, being able to have those moments of discourse. Now, I want us to think also in terms of the way we question our students. So most of the time, when I was a brand new baby teacher, I stuck to answer getting questions. And they have a time and place, but when I'm trying to fully understand what my students know, it's not a great space for me to be in. I can ask, what is evaporation? And they can recite, regurgitate whatever definition I've taught them, but are they able to make sense of that? So why not change our questions from answer getting to sense making? So instead of asking a student, what is evaporation on a test? And they just, whether it be multiple choice or fill in the blank, why did the puddle disappear after the storm? They can draw me a picture. They can walk me through what's happening. I could ask a question, define ecosystem, or I could make it better and say, tell me why the grass changed as the rabbit population increased. What was there a problem? And I could scaffold that. Why was it a problem? So the kids realize, like, oh, it wasn't a good thing, to help remind them that what do rabbits eat? All right, so the way we ask questions can feed into our talk moves. So talk moves in science are where we are encouraging our students to say more, or I might have someone revoice. I do that a lot with my own child who's really young. I might paraphrase what he told me just so he can hear it back to make sure I understood what he was trying to say. And it's a way for him to be metacognitive and thinking, no, that's not what I meant. I meant it like this. And so he can restate. I can ask him, I need evidence on that. Like, why do you think that? Or another student can raise their hand and say, I want to add on to what they said. They can agree or disagree, but they have to tell me why. They can link ideas, and think time is a talk move. I want my kids to think before they start sharing, because some kids do need extra time to process what they want to share. And then paraphrasing. Shoulder buddies, turn and talk. Those are great ways to lower the stakes for kids so they're not so afraid to share out to the whole class. It's given them practice to say it before they share out. It also gives them practice before they put it to paper. So it helps ease that writing fear as well. So it reveals thinking. This is a really great way to have formative assessment happening to check for understanding. It allows for real-time feedback and that flexibility to adjust my instruction in the moment based on what we are talking about in the classroom. Another way to build discourse conversation, I like to play four corners, and I'm the devil's advocate a lot of times. I will purposely put up four options that are all true. And then I love having them fight it out through argument to argue who is correct, and then them realizing, wait, they're all they're all correct. I don't do it every time, because then they would get in the habit of knowing, like, well, everyone's going to be a right choice. But I do like to throw those in here and there just to really give them a run for their money. But it's such great conversation. So I put up a picture, and then I'll give four options. So my classroom corners stay numbered. So, 1, 2, 3, 4. And then the choices they have to pick from are typically 1, 2, 3, 4. And then they'll just move to the corner that they want to go to. So here I've got tornado debris. Okay, so maybe we're talking about weather. Obviously, depending on what has happened with the students and the time leading up to this, I might be a little bit more cautious of pictures that I share. But here I could show, here's Sulphur, Oklahoma. I've got the left side of the picture. Everything looks pretty good. The right side and beyond that was just terrible. Like, everything was destroyed. This is my house, and these two pictures actually need to be flip-flopped. So this log cabin is my house, And then over here off the side of the picture is where this airplane hangar sits. And so the tornado came between them and it I mean, you see the damage here. This is my hangar. The two airplanes that were inside, we no longer have. They're gone. And everything was destroyed. But it wasn't a direct hit. So my question to my students is, why, like my house and my airplane hangar are in the same path with the tornado. One's on one side, one's on the other, and the tornado went between them. Why would this be the destruction to my farm? And then also look at the picture of sulfur. So similar idea, one side of the street, everything, it almost looks fine. I mean, if you zoomed in, you'd start to see damage, but then the other side of the street is pretty bad. So we have four options here. The tornado randomly destroys things, wind speed and direction change, building materials and structure make a difference, or air pressure differences cause certain homes to have their windows blow out. So when kids try to process this, some of these might all be true. Maybe not all of them, but some of them. So they may end up in corners where they both think they're right, and technically they are. But I like to get kids thinking. So what evidence is supporting what you're saying, or who can restate that? Does anyone want to add on or challenge that? Like those are the questions I'm going to be asking my kids as they pick corners. And they're huddled up trying to defend the corner that they, as a team, selected. So that's one option. Another one, prairie after fire. So during the week, my husband's a police officer down in Frederick, Oklahoma. So that's where we go on the weekends. And this is the wildlife refuge. And so, you know, in the wildlife refuge and around Fort Sill, they do controlled burns at certain times of the year. And after a fire, the grass often grows back really pretty, really thick. You see in the bottom picture, there's lots of wildflower. So why are we doing these controlled burns? Fire adds nutrients to the soil, removes competing plants. Plants adapted to survive will regrow. Um, the heat from the fire can help seeds. So this one is a trick because they all are valid, but getting my kids to think through those, I think, is really important. And then my favorite one is, where does dead stuff go? So this is how I start fifth grade. We start with energy and matter, and I just start the school year with a picture of my little raccoon on the screen, and I ask, or well, I tell them my brother lives in South Carolina and he was driving to school today. He lives in the mountains and he drove past this sleeping raccoon. And what do you think's going to happen to the raccoon? And the kids are like, Miss Sizelove, I don't think it's sleeping. I'm like, well, he's going to check on it tomorrow. We'll see. He looks like he's taking a nap though. And so having that conversation, the notice, what do you notice? What do you think is happening? What questions do you have? And so then, we start to realize the raccoon doesn't go anywhere. Well, it does actually. It finally disappears. So what happened to it? So it disappears, it gets eaten, it becomes a gas, it turns into soil. Again, all of those are possibilities. But getting kids to start this unit, having this argument, allows me to hear the misconceptions we're about to get into that I'm going to need to address with some of my kids. And it also lets me see what they come in already knowing. So again, another really great formative assessment as we start a unit of study in science class. So it gives students a moment to get up out of their seats. It's going to build that engagement and then that metacognition of the choices they are making, right? So I love having these. All right. So of those activities, are there some that you use and love? Do you have any ideas, any others that you would like to share with the group? What would you adapt? Just take a moment in the chat to drop in some ideas. Or you can unmute. You're always welcome to share out. I know Brenda's back there. Like the wildlife or the refuge. I can attach that to social studies all day long. And stability and change. Like I can already see her mind going with all the stuff. I like the Oh Dear game. How do you, oh, so you would just have hunters, and so a hunter like would be a student, and they just grab a deer. So now they've grabbed a deer. If I were still in the classroom, yeah, it's fun. And so I love all the lessons that come out of Project Wet, Project Wild, Project Learning Tree. They're all outside activities, get kids moving, and you can tie them to the content areas. Lots of ideas to be tweaked to fit so many subjects, definitely. Yes. And think about all of these, you could also do a writing assignment. So I joke, uh, I mean, I really do more writing in my science class than the ELA teacher did. And she would use my students' writing samples to also be doing things in her classroom as well, kind of see where they needed more instruction. But writing needs to be happening all the time because that's my window into what they know, especially in the older grades. All right, thank you for sharing. So to wrap up, just that reminder, when students move, when they talk, it allows them to make sense of that phenomena. It allows our learning to become three-dimensional. And so when we talk about three-dimensional science, this is what we want. We want kids explaining and doing and setting up experiments and collecting data and having that discourse and getting that evidence to support their disagreements. Brenda says we use four corners in social studies also, and the group has to justify their reason or claim for choosing that corner. I love that. Yeah, it's such a great one to use in all the content areas. So how do I manage movements? Depending on the activity, like with my robotics kids, they always knew when they came in, they were going to have assigned jobs and the jobs rotate. So just like that, I have roles when we're going to be doing some sort of moving model. Someone's going to be the materials person, the evidence recorder, the discussion lead. Depending on how big my groups need to be, I'll come up with extra roles. I always have my students turn and talk before they raise their hand to do a whole group conversation. That gives everybody a chance to practice what they want to say. And if they don't want to share out to a whole group, they've at least shared it out to a smaller group. And I like to just go around and listen as they're doing the turn and talk. I do use the randomizer. I always use Clash Dojo, and it would just spin and I'd pick my students. Some teachers like name sticks, whatever you like, just to encourage that randomness to get kids feeling comfortable. And then sentence stems, I like to give my students sentences on the walls to kind of help make them feel very scientific. So they'll have little sentence starters and we practice filling in the blanks so that they feel like they're talking like a scientist as we're discussing the topic at hand. All right. And then we've already kind of reflected on those strategies and thinking about your first week back. As I'm kind of wrapping up, kind of showing a few more things, if there's anything else you want to share for that first week back in the classroom, I know that's coming up really soon. But I'm going to walk you guys through that one-page document that I just put out there. I'll walk you through those resources. Please ask any questions. You can put them in the chat. Rory and Brenda will kind of be watching the chat for me to let me know if there's a question. And I also have these resources here. So let me exit out of this. I'm going to go to Control V. Brenda said culture is a huge part of social studies, and you can talk about culture, traditions of the community that live next to this habitat, like interacting with the environments, enhancing the, yeah, oh, absolutely. There's so many connections you can make. All right, so let me walk you through what you're seeing with that one pager. Let me make sure you're seeing what I'm seeing. Yes, okay. So up at the top, this link just takes you to my email address. The Standards in Learning website would be next. Over on the left-hand side, the first link, the Using Movement to Drive Three-Dimensional Learning, that's this presentation that I just walked you guys through. Oh dear, you have a YouTube video. There's a PDF lesson example that's more geared for middle school, high school. And if you need me to help you try to like see how this looks as you move down into the younger grades, just email me and we can collaborate. Here's a look inside of a classroom where students are having conversation in a three-dimensional sense-making capacity. So I really like this video. If you're trying to find ways to have talk happening in your science classroom, there's these resource cards. So I put that PDF there for you to have. The Wonder of Science graphics and tools. I live for graphic organizers. It's a big part of letters. And so if I'm, working through a graphic organizer to understand the science, I also want them using a graphic organizer to be writing about the science. So just same thing that you're doing in ELA, I'm going to be pulling into my science and social studies classroom as well. The additional resources, so these are the Lunch and Learn. This is the link for you to get into those. The OSDE frameworks for every content area. Those are a great resource. There's pacing for you. I'm updating with our new standards. I know Brenda's working and has our social studies ready to go for you guys as well. And her social studies standards, I believe, are going to be available as of today. So yay, they're posted. Excellent. Our academic standards are on the website at that link. What Works Clearinghouse is super helpful for all subject areas. Just lots of research there if you wanted that. Our elementary ed chats from last year. This is the YouTube list of those videos. We've got our family guides. Sam Noble, if you're ever wanting hands-on kits to use to help build out your work with your students in a engaging way. We've got the History Center with their travel trunks, and Sam Noble has their discovery kits. The History Museum, if you team up with Bank First will usually cover the shipping cost. Sam Noble, they just ship them for free. So I attached the link there for Sam Noble's. Feel free to request them. They have them all the way from pre-K to 12th grade. The monthly updates, we don't currently have monthly newsletters being emailed to you. So if you'd like to kind of keep up with each of the content areas, the monthly updates just take you to those. And I'll be putting in like one summer update here pretty soon to feed us into the start of the school year. A framework for K-12 science education. If you want more of a background in our standards, this is where that all comes from. Oh yeah, Brenda said she's met teachers on the turnpike with history trunks. I'll do the same. Like I said, I'm either in the Shawnee areas where I live during the week, or I'm down in Frederick on the weekends. I'm happy to go either direction to get you materials. Okay, Satchel is a new place for our standards, and this makes them digital. So if you prefer to have all the standards in one digital platform where they are not PDFs, this is a great place to go, and they translate into multiple languages. I use a lot of Oklahoma Ag in the classroom. Their teacher tools are fantastic. And then I also included the links to Project Learning Tree, Project Wet, and Project Wild. So I just wanted you, I know it's a lot of resources to give you at one time, but I wanted to make sure you guys had those. I also, let me go back to our presentation. Where'd it go? Oh, wait, here it is. Okay. So let me share the QR code to kind of wrap up for today. Once you fill out this QR code, Rory will make sure you get your certificate for attending today. If there are any questions, please feel free to unmute. I'll stay on. If you want to talk, if you want to put anything in the chat, let me know. I'm so excited you all were here with us today. Thank you so much for giving us an hour of your time, and I look forward to collaborating with you all in the future. If you ever need us to come out and support you with standards, professional developments, just let me know. And for letters, I don't know. Send me an email and I'll find out for you. I know, no, okay, because I was like, I know Ames, I think has, like, they're going to do that one and then that's it. But letters maybe not happening for the time being. All right. Again, thank you so much for being here today, and I appreciate any and all feedback. And again, let me know if I can ever help support in any capacity. Brenda's always happy to help. Rory's always happy to help. We've got a whole team here that is here to support you.